Good afternoon. This is Preston Mwinga, and I'll be looking at the spatial analysis. Okay. Yeah, we'll be able to answer a few questions, support decisions, reveal patterns. Okay. So all transformations, manipulations, and method. A set of methods whose change when locations being analyzed, uh, which is spatial analysis. So calculation, which is spatial analysis. Is it calculation or maybe calculating the average income for the group of people, calculating the center of the United States population, types of spatial analysis. So we have queries reasoning, measurements, aspects of geographic data, area, length, transformations. We're talking about new data, raster to vector, geometric rules, descriptive summaries. So instance in 1 and 2 parameters, optimization, that is ideal location and routes, hypothesis, sample of the entire pole. GIS analysis model, which is a flowchart. So residential area in a flood zone, but needs spatial analysis to pinpoint locations. For example, the flood zone. So land use, there's a query there, residential, flood zone, we have queries, and takes us to wet homes. GIS landslide, susceptible model, in arc model. Okay. Um, hello, bomul kwanje. Eh, or stuff like that. Nope, supply koti. Singaboy kunchito mai. Mm. Mzaka nipeza kunchito. Mm. Oh, all right. Ziko. Okay. GIS landslide, successful model in ArcGIS, and that is what we have. Yeah. Analysis, examples from ArcGIS. So interpolation, that is, we're talking about soil samples on a farm, transformation, location analysis, we're talking about coffee shops and customers. A set of methods whose results change when the localization of object is being analyzed. Interpolation, okay, we're simply talking about the sample. So a sample of the farm area, interpolation. So this is how they appear in ArcMap. Interpolate samples, then query to find the pH, okay? So we have sample, interpolate surface to tell us the pH sample, pH surface, then query the pH treatment areas. So that is how they're being entered in weight. Okay. And we have the IDW interpolation. Instead of hillside, use raster calculation. So this is how it's being done. So the farm, okay. So a set of methods Whose has changed when the localization of the object is being analyzed. So interpolation, okay. So there we are. Marketing questions. Uh, too close to existing shops, similar to existing locations. Where are the competitors? Where are the customers? Where are the customers that are spending the most money? Okay, so they should be able to help us. So shops W in one more compete for customers. Okay, so GIS analysis model will have shops which take us from distance, means distance to shops, and then the other side we have customers, density, spending density. Then we need to find the best location, and this is how it's done. Okay, there we are. This is in the arc map. Okay, and we continue. So result based locations for a new binary. Okay, so there we are with our flow chart, and it has all the data that it needs. Visualization and spatial analysis. An example from the district. Okay, so we have that website. Uncertainty in the conception, measurement, and representation of geographic phenomena. So previous samples assumed it didn't exist. Then conception of geographical phenomena. Uncertainty. So uncertainty of the geographical or phenomena. So conception of what are the spatial vagueness, ambiguity, then there measurement, meaning a field digitizing lineage, representation, raster vector, and in analysis, ecological balance. This has been Pressoninger. Till next time. It's bye for now.